This is video 2 for project number 4, the one in which we write the actual function. Let's get MATLAB, edit, go function. We're returning nothing, so I'll use dummy as my variable name equals I'll go lens calculator, and it's supposed to take 2 arguments, the focal length of the lens, I call it f, and the object distance. I'm going to use lowercase o for that. Put an end for the function statement, tab over so the body is indented, and take a look at what I was planning on doing here. So calculate the image distance. I'm going to use I equals I think it was 1 over f minus 1 over o, reciprocal. So 1 divided by the quantity 1 slash f minus 1 slash o, and take a quick look at that, make sure I got that right. Yep, and then calculate the magnification. M equals minus I over O. I don't need to print everything out. And I calculate there. Alright. Then what did I say I was going to do? If f is less than 0, so what kind of lens it is. So if f less than 0, display. I think I'll go ahead and do this on a different line. So display single quote the lens is a diverging lens, in single quote, end argument, backspace to else, disp, the lens is a converging lens. Instead of die, and then an end for the if structure. Okay, then what do we have? The focal length of the lens. I want to print the focal length of the lens. I think I'm going to number these things. 1. Alright, display the focal length is, and I think I need an array here, so it's going to be a 1-row array with 2 elements. This, I'm going to put a space there. I'm going to make it kind of right, comma. Then the next element of the array is num to string of f. A string of characters is what we think of as text, and the value of the focal length is stored as a value, so this converts the number that is stored in F to a string, so it can be displayed as text. And then that's the end of the array. It just had 2 elements. It's a 1 by 2 array. And then close the argument list for the function. It's just got 1 argument, that 1 array. And I think I'm ready to look at the next one. That was supposed to be item 2 on my list. Next. Alrighty. So focal length the lens is, and now the object distance is num to string of O. So display to the screen, or print to the screen. This is item 3. The object distance is, and then comma, num to string of O. And then that's the last element in my array, and then that's the last bit of the argument list. That space doesn't matter, it just makes it easier for the humans to read it. Well, let's see what the next thing is. The image distance is. Control C, Control V. Image. That's the 4th thing in my list of things I want to print. And it's I. Alright. Next. If I is less than 0, say that it's virtual, otherwise say it's real. So I think what I'm going to do is copy down this if structure that I got up here. Change that to I. We're up to item 5. The image is virtual. The image is real. Okay, that was item 5. Then, if m is less than 0, print the image is inverted. So another if structure. Copy and paste. Actually, okay with that. I got a little extra space around it. I'll do that for all of them. Make them stand out a little bit more. Alright, but this was supposed to be if m is less than 0, and it's the 6th thing I want to print out. The image is inverted. This I called right side up. It's a sentence, I should put a period. Technically this should have a period as well, but then you get mixed up with the decimal. So you go with colons after that. space. And then what do we want to print? The magnification of the lens is such and such. Control C, Control V. It's the seventh thing. Magnification. Did I say up the lens? I think I'll keep it. Yeah. The lens. It's the magnification of the object now. I'll call it the magnification of the lens. And it's going to be M. Let's try saving it. Lens calculator. And let's try running it. Lens calculator. And I got a focal length of 0.4 meters and 0.8 meters for the object distance. So I'm expecting real inverted, and I should probably calculate it to see. Oh, I left out the units for those first three printouts. But focal length is 0.4, object distance 0.8, the image distance 1 over 0.4. Yeah, let's just make it 2 and 4. Oops. Two and 4. Then it's converging to 4. Image distance 1 over f would be a half, minus 1 over o would be a fourth. 1/2 minus 1/4 is 1/4. Reciprocal of that is a 4. Is 4. So that looks good. It's real. It's inverted, and it is -1. The minus sign means that it's inverted. Okay, but I got to get some units. So go over to the editor. I think I got no problem with the sentence if I got units on there. So, comma. That's a bad example. I'll leave that as a colon. Magnification has no units. Bad one to start with. Alright, so comma, and then the units are meters. I think they're all going to be meters, so I'm going to copy that. Control S to save it, and then try running it again. This time, I think I'll put space meters. This time it does have units. The lens is a converging lens. The focal length of the lens is 2 meters. The object distance is 4 meters. The image distance is 4 meters. The image is real. The image is inverted. The magnification of the lens is -1. And let's try it. If I'm inside the focal length, I expect virtual image. Let's see if that works out. So I'll try running it with the object closer to the lens than the focal point. Image distance is a minus. The image is virtual and it's right side up. It's looking pretty good. Let's try a diverging lens. And I'll be outside. So this, I think, brings it closer to the lens than the object is. It's at a 4, so I think we're closer to the lens than that. But it's still virtual. So it is virtual, right side up, magnification, a 1/3, and the image distance, yeah, it is closer. Now what happens if we get inside the lens? Inside the focal point. So I'll put this at 1. And that better be virtual. And that part I can test. Diverging lens, minus 2 meters, 1 meter, that is what I said. The image is virtual, right side up, the magnification of the lens, 0.667, so where was it anyway? Oh, so it's, yeah, that makes sense, it's even closer. So the light diverges from an object and then the lens makes it diverge even more. So it's even closer to the lens than the object was. Alright, I think this thing is working. Let's call it a wrap for Project 4, video number 2.